So I've kind of, you know, gotten carried away a bit, and I've already given you some spoilers of what came next. But just, you know, to reiterate the most important concepts in Python. So when we create variables, what's happening is that we're creating some data which gets stored in the memory, in the RAM memory of our machine, and our variable is simply a pointer to that location in memory which is storing that data. Okay. So let's say we have x equals red, y equals yellow, and then z equals x. Okay, I mean, we already know a lot of what's going on in these three lines. We know that x, y, and z are all variables. We know that the equal operator binds a variable to a data item in memory. We already know that if the variable already exists, it simply rebinds it. Otherwise, it creates the variable and binds it to the data item on the right of the equal sign. So basically, if x was or had already a value before, let's say x equals 1 and then x equals red, this gets that there's a rebinding of the value of x. Now, the interesting case is this one, z equals x. Now, in this case, we're binding c to a variable that already exists. So when we run this, these two guys become the same. So both of them are pointing to the same item in memory. And actually, there would be a way to check that because you can have different variables with the same value, but this doesn't mean they are pointing to the same place in memory. But you can actually have two values which are pointing to the same place in memory, and that would happen when you assign them, when you assign one variable to another. How is this relevant to us? Well, for now, not really, but it may be the case that if we write a longer program and we are playing with two variables, how do we know if we modify one, if the other one is going to stay the same or not? So we can have some check in our program that, you know, checks whether both of these variables are actually assigned to the same location in memory. We're not going to look into this because I don't think that's material for beginners, but just for you to know that this would be a source of bugs or issues in a program when we expect two variables to behave independently, but somehow we messed up the writing of the code and both of them are pointing to the same item in memory. So let's say we multiply by 2, but we expect one variable to be double and the other one stay the same, but it turns out that both of them get multiplied by 2. Just a couple words about how to name a variable. We could, you know, do a lengthy exercise on what are and are not valid variable names. TLDR, don't get too creative with the naming of your variables. A variable can only contain letters, numbers, and underscores, but it cannot start with a number. So either must begin with a letter or an underscore. And it cannot be one of the Python keywords. So like, for example, print or others that we will see along the way. They are case sensitive. So my var in capital, starting with uppercase, or everything in uppercase are different variable names, which is good. And as you can see here, we've got a few variable names. And I am not going to run this cell, but I am just going to point to the fact that here the 10 has a different syntax highlighting in Colab depending on whether it's part of a valid it's part of a certain operation or not. So you can use this as a hint to kind of know if your variable naming is correct or not. But anyway, I just did Control Z. Okay. But yeah, anyway, the takeaway message in variable naming is, especially if we're starting, let's write variable names that are self-explanatory, so not too short. X equals Y equals, it's okay for this tutorial, but if you actually want to know what your program is doing, it's way better to use longer variable names, even if sometimes it gets a bit verbose, especially at the beginning, it's a big help. And yeah, and finally, an illustrated discussion of what dynamic typing means, which I already hinted in one of the previous sections. So if we have a variable which points to the item 5 in memory and we rebind it to another value, for example, hello, it simply gets rebinded, right? So there's not another B created, another pointer. This doesn't need to disappear regardless of whether there's a variable pointing at it or not. Okay. So this is an example of how clean, and this can open a Pandora box. That's why I want to stress the fact that this is very convenient when we're starting to learn, but we need to be conscious of the capacity of Python to switch from one type to another dynamically. So what can we do with all this, right? So we've done a lot of stuff. And then eventually we end up with a very good calculator, right? It's not exactly that, but that's not, it's not a lie either, right? So we can have actually some very powerful numerical computation only with what, 1 hour and 5 minutes, or roughly 1 hour of tutorial. So we can take the value of A and B, A plus B. We can have them multiplied with each other, and we can have some conditional execution here. So A plus B greater than 2 is okay. A and B, A plus B greater than 4 is false. Let me run this. And because this is true and this one is not true, the overall statement is true, so the final output is true. Okay. So it's time to move to the types, right? So I kept saying that Python can be used as a very good calculator because we can mix certain conditional operators, and we can deal with different types of data, and we've seen numbers and strings of text, sequences of characters, but actually there are other types, no? So what we're going to do, we're going to look a little bit more in detail into each of the types, and we're going to say a couple more things about the ones that we've already seen because they deserve it. This is like the bread and butter of Python programming. So that's why we're spending quite a lot of time on this. I like it a lot when certain educational material doesn't hand wave anything. So this is why we're stopping in every single little detail that I can think of to make sure that everything gets understood as we go along. Okay, so there are several types in Python. The ones that you're going to be dealing mostly are the numbers, which we already saw. We already saw integers, in this error. Well, I'm not going to go all the way back, but in this error where we try to add a number and a string of text, and Python complained because it could not add a str object and an int object. So this stands for integer. And again, these are numbers that are no decimal values, and they can be negative or positive, as opposed to floating point numbers or floats, which can have decimals, right? Strings of text. Then the Boolean type. Well, bear with me a minute. I'm going to drink some water. Okay. So you would actually be surprised of how much of the software engineering, of software engineering in general boils down to binary decisions. If you think about it, many, I said, no, there's this conditional execution and repetition, but all of that boils down to yes, no decision. Is this is this happening or not? If this happens, do this. If it doesn't, do something else. The thing is that there's not only one. These get branched out quite extensively to generate business logic in the back end of an application written in code. So because these binary decisions are so important in computer programming, we even have a type for them, and they're called the Boolean type. And the Boolean type can only take one of two values, true or false, and it also evaluates to a numerical value. So false will be interpreted by Python also as a 0, and true will be this is not it's a bit oxymoronic, but we're not going to, so this is not entirely true. True is evaluates to 1, yes, but it actually anything that is not 0 will evaluate to true. I'll repeat that. Anything that does not evaluate to 0 will or no data, null. As long as we have something in our program, Python will not evaluate it as false. So, and again, if this sounds a bit convoluted, yeah, what can I do? No, that's how it works. I'm sure that it will make sense after we run this cell. But the bigger picture can be summarized as this. False can evaluate to 0, and true can evaluate to 1, and this is also true. And this has a very interesting consequence, and it's that false and true values can be used in numerical calculations as well. Okay. So what happens if we run this cell? First, we're getting the type of the false value, which is a Boolean value. So this is not false. It's actually telling us that this guy here is of the Boolean type. Okay. However, if we wrap it into single quotes, this is not Boolean anymore, because then the type of this is a string. Okay, as you can see, the blue color is already telling us that these are not, regular variable names expected by Python, which would be printed in black in Colab, but actually they are something else. Now, what we are doing here is to take the number 1 and change its type to the Boolean type. Okay, so I'll say it again. We're taking a value and we're recasting it to another type. Sometimes you can do it, sometimes you can't. This is the same principle as with trying to add a number and a string of text. But I just said that you can have that the ones and zeros, because false and true behave as numbers. Conversely, numbers also can behave as false and true values. So it's actually possible to get the Boolean value of 1, which is true, and the Boolean value of 0, which is false. I'm quite tempted to show you something. Okay, so let's turn this 0 into a string. Let's run this. I don't want anybody typing on the chat. Let's just think this third line here, which is going to correspond to this print statement. We're going to try to convert this into the Boolean type. Now, Boolean type can also have false or true value. We're trying to take the string 0 and make it Boolean. What Boolean value could it be? I mean, we don't know any Python, right? So we can't possibly know. But just as kind of an interesting exercise. So in case someone was thinking, well, it should be a 0 because it's a 0, it's actually not, because 0 only works for the numerical value. If we turn this 0 into a string, this is virtually, Python will treat this exactly the same as saying, I don't know, Spain is a country in the south of Europe. So the Boolean value, Europe. So the Boolean value of this string is still true, right? Now, What would be a string value that would evaluate to false? The void, nothingness, an empty string. In that case, this guy here, the Boolean value of having an empty string is false. Okay. The type of false is Boolean, and of course the type of true is Boolean. And this is the non-type. The non-type is a different thing than the false type. We said this is for beginners. You're not expected to to make sense of all this from the beginning. Just think of none, and I think I say it further down. Yeah, so let's just let's follow this. A special type known as the null object, it has no attributes and always evaluates to false. So think of none as the absence of data, right? So I think this would be a good definition. Okay. Numbers, integers and floats. So 19 minus 12, or this very long number will be evaluated as integers. Numbers with decimals will be evaluated as floats. Okay, so let's have a look at this. We have my number. My number is 1. We print the float version of my number, and what Python does is to print that same number, but with a decimal. But it's the same, right? Now we can have a decimal or floating point number assigned to the variable my number, and if we try to do the same, but the other way, to recast this floating point variable into an integer, it will get rid of the decimals. It will not try to round it up. Okay, so this is important. So if we have 2.9999999, it will still be 2. It will not try to round it to 3. Okay. Okay, we've come to one, almost the last, the last, because we already talked about none. The last type that we're going to be interested in today, which is the string type. A string is a sequence, and you may say, hey, but you have sequences here, and we're supposed to be covering this today. Yes, we are, and yes, we will. But string is a sequence, but it's a very, like a list, like the list of fruits. So this string type is also a sequence. It's a sequence of characters, but let's treat it in a different way. It's a sequence, and the meaning of the meaning of this sentence here, string is a sequence. This means that we can do things on strings just like we would do on lists or any types of sequences. So when we look at sequences, just remember that much of the stuff that we can do to manipulate sequences, we would be able to do it on strings. Not everything, but much of that. However, a string of text is something very special. So we don't really want to treat it simply as another sequence type. We're going to treat it as its own type. How do we define strings? Well, we already know that we can encode them in single quotes because this is what we've seen throughout the tutorial, but we can use double quotes and even triple single or triple double quotes. So why all this? Why do we need 4 different ways to define strings? Because this is the same, right? So A equals this is a valid string and B equals this is another valid string. What's the difference? Why would I want to do this? Well, I'll tell you why. First, because with triple quotations, whether they are single, triple quotes, 3 quotes, 3 quote signs, whether they are single or double, we can have multi-line strings, okay? So this is very convenient. Let's say, for example, I print the variable A. So we don't care. We're not going to stop too long for in what we have in this cell, because in the end, what we're going to see when I run this cell is simply the value of A. Value of A is, this is a valid string. So if nothing gets broken, indeed, this is a valid string. And if I print B, nothing crazy, right? If I actually print C, I can see that C contains these lines one after the other. Could I do this with single quotes? No. Python will believe that I have initialized a variable assignment, I have started the string, but then for some reason I didn't do anything with this. But then Python here believes this is another line of code. It has already, it will break here anyway, but as you can see, there's no way for Python to know that what we want to do is to enclose this as a full string if we don't tell it. Otherwise, it will treat this as new lines of code. Okay, so 3 quotes here and 3 quotes here. I am going to say something else. So you see I have printed this C. If I wanted to check the contents of that variable and of variables in general in the notebooks, I don't really need to print it. I could simply type the variable. But there will be a difference here. C will not print the value of C, will show me the content, the data that Python has stored in this value. And you will probably say, yeah, but this is the same, right? It's not exactly the same. The content of C is a string. So this is what C contains. And as you can see, at the end of each of these lines, Python has appended a \n, which is the symbol used for denoting a new line. Another one here, 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 and because I have the closing triple quotes in another line, I also have one at the end. But if I print it, these guys actually get converted into what they are when they print, when they get rendered into the standard output or console. Okay. Now you can do, and this is the last thing I'm going to say about this difference between printing and not printing. If I print B and print C, of course I will print B and then I will print C. And then you could say, hey, Luis said that I can do B and C, so let's just check them out. This will not work for you. It will only show you the content of the last variable of the cell. Okay, so I got plenty of cases where people thought there was a bug in their program because they were used to do this instead of printing. This is why even if I don't need it, it's good practice to use print all the time, simply because you avoid cases where, and this is a behavior of the notebook. I mean, this is not something that you would even do in Python, because in Python, in regular, writing a program and run it and see how it works, to check what something spits out, you print it out, right? And of course, print D, it's the same. Now, why do we want single and double quotes? Well, the reason for this, even if this is the same, is because we may want to have quotes inside our string. Let's say you've got someone's being ironic and says, yeah, this is a linear algebra quote course. If you don't use single quotes as the outer delimiters of the string, what's going to happen is that Python will interpret this string. Okay, so what I did was convert. You see, Python believes, okay, this is the end of the string, and this is some other Python code, and this is for some reason another string. So of course this is not going to work. Python will say that this is invalid syntax probably. Yeah, because Python doesn't know how to interpret this. Okay, so we need to play a little bit with this. This is going to work. We're only printing B, but Python didn't complain. And the other way around. So this possessive marker we will not be able to use it if we wrap our strings with single quote, if we have a single quote in there. Okay. And there are other reasons, but just, these are very obvious reasons why we are allowed to use the two types of quotes in defining strings. Okay, and then we got the none type, which we already talked about. I already said a couple things about comments, but yeah, the reason, well, long and complex programs might be difficult to read. Even short programs can be difficult to read, right? So even, in general, programming can, it's never too much. Well, sometimes it's too much, but let's just assume that it's never too much. There's never too much commenting in code, especially if you're learning. You really appreciate if someone else's code is well documented and then tell you exactly what the program is doing. Things that are self-explanatory are not needed. So if comment saying, I don't know, a equals 1. Here I declare a variable with one value. Well, that's okay, but I already know, not right? But maybe I am using some third-party software in my program. So instead of asking someone else to go online and read what that software is doing, maybe I write a couple comments and you save me a lot of time. They are written after the pound sign, or we can have multi-line comments with exactly the same notation as we had for strings. Okay, so we can actually have a comment here, and when we run some code, Python will effectively ignore this and move to the print command straight up. Okay, it's 3:30. So we're going to look at okay, so I'll give you a little bit of context. So if you have checked the webinar description that we had in the website, we put dealing with files and program flow. But as you can see, we're not going to cover those as well today. And the reason is we've spent quite a extensive effort in distilling the most basic fundamentals of the program, of the language, because for sure this is going to prevent many unwanted errors and mistakes that typically happen when you do some, you follow some educational material and some of the things maybe are taken for granted or are expected to be known. But proper from scratch means proper from scratch, right? So we're not going to cover files and program flow other than the small, teaser with the if-else statement we saw at the beginning. But for sure, this will be one of the first things that we will cover in the next session. But now that you have had a little bit of exposure to Python, understanding program flow and files should be fine, and then you can reinforce when we reconvene in the next session. So the last new bit of context that we're going to see is sequences, as you can see here. No, so I already have we already have the materials ready for program flow and so on, but in the interest of time, instead of rushing through all this stuff, we left it out, and we're going to cover it in the next session. So the last bit of content we're going to see is sequences. Sequences. Collections of elements. I mean, this is like super important. It's super important, and you will see that with having access to a little bit of conditional logic, numbers, text, and some program flow, and especially sequences, well, there's so much we can do. But we do need sequences to make things, to be able to. Sequences are data types that fit well with the conditional execution, with and especially the repetition. So definitely a major player in learning Python. We've got different types of sequences. One of them is the string type, as you probably remember, but we've treated it a little bit differently because it does behave differently sometimes. They're ordered and unordered sequences. And we'll say a couple things about that in a minute. But the fact that by default, a sequence, when we define it, even if we, because we think in 2 dimensions and well, in 3 dimensions, but the screen only has 2 dimensions, and we have to put things in order, one after the other, separated by a comma, etc., etc. Once they get assigned to a variable as an unordered sequence, they lose the order. So what we define to be in the first position, ultimately it's stored in the 5th position. So why is that even a thing? Well, there are a number of reasons for that. But if we wanted to check, for example, the first element of a list, we can do that because the list is ordered. But if we wanted to do that with another type of sequence which is not ordered, we would not be able to do that, and Python would complain because it would tell you that this sequence does not support indexing. You cannot take the index 1, index 2, index 3. One of the reasons why we have unordered sequences is because it's much faster to do the membership operation. So checking if something is included in a sequence, like for example, this example we saw at the beginning, checking whether 1 existed, was included in this list 1, 3, 5, 7, da, da, da. Or no, I think it was a 5. If you do it on an ordered sequence, you actually have to check for each of the elements in order because the order matters, right? But that's not necessary in an unordered data structure, which means that checking whether something exists in an unordered data structure is much faster. And if we have to perform this operation millions of times, this is something that we may want to do. Okay, Luis, but which are the ordered and which are the unordered sequences? Okay, so I already told you that lists are ordered. They are denoted by these square brackets, as you already saw. A list can have anything, and our code can change it. So we can define a list with a bunch of stuff, and as you saw in the example with Carrot, we were able to modify the contents of that list because we could add and remove Carrot as we wanted. Well, we did that in the definition, but we could do that programmatically. But we cannot do that programmatically, for example, with another type of sequence, which is the tuple, which is denoted with by round brackets. It's exactly the same as a list. They can also have anything we want. They are also ordered, but once they are created, your program, and not yourself, you can change it. When you define it, you can change them, but your program cannot change it. They're less flexible, but more efficient. So in terms of efficiency, let's think of an array of efficiency. Least efficient, the list, because it is ordered and you can change it. So it takes more CPU resources to do operations on them. But if your program already knows that the list cannot be modified, there are certain things that the program doesn't need to check for. So this is why you may want to have a tuple. And if the order doesn't matter, you can have a set, which is denoted by round curly braces. And they are not ordered. So we will not know in which position each element is, regardless of the ordering we use when we define them. And sets can indeed be changed after being created. Okay, so how does this translate to Python code? Well, so let's define a list. As I said, a list can have basically anything. Well, most sequences can have almost anything, right? So we can have 1 and 2, we can have tres, which is Spanish for 3, we can have 4, we can have a Python function in here. You can throw whatever you want. Let's throw another list, an empty list. Okay, so it doesn't really matter. They can store anything we want. A tuple is defined just like the list, but with round brackets. And a set is defined like this. And let's print out these guys. So as you can see, we printed the list, which contains 1, 2, 3, 4, a function, a Python function, built-in function print. Why would we want to do that? Well, I don't know, but just to show that you can really throw in there whatever you want, and then an empty list. Here's a tuple, and we have the sorted function. So as you can imagine, this is a function for sorting stuff. So 3, 2, 5, sorted would be 2, 3, 5. And a set, which has this function here. So let's actually print each of these variables and their type. The type, and the type. And as you can see, L is a list, T is a tuple, and S is a set. Okay. We can access elements. We can access elements in different ways. We can access one single element by position, and with that we use so we can access one single element by position, or we can get a slice, so we can get a subset of the sequence, and in both cases we would be using this round bracket notation. We pass a single number for a single element retrieval, which is going to tell Python, I want the element at that position. But this is very important. I put it in italics, but actually, let's put it in bold because it needs to be, this is very important. In Python, we start counting from 0. Let's get rid of the dot here. Yeah, full stop, out. Okay, in Python, we start counting from 0. Very important. A lot of bugs will come because we believe that the index is in one position, but it actually is one position later because we started counting from 0, actually one position earlier, one position before. And we can also access, start counting from the last element of a sequence, starting in position -1. And we also can access subsets of the sequences. So we can pass to our square bracket notation 2 numbers separated by a colon, and these denote the start and end index. Okay, so yeah, so I have a couple of notes here, but I'll talk about them with code, which will make things clearer. Let's say we've got a list of modules: philosophy, maths, music, engineering. Music is repeated, so we probably don't want it. And I want to get the element at position 0. That's going to be philosophy. If I do element at position -1, we start counting from here. Of course, the last element of the list is not -0, right? Because -0 is 0, so it would be this guy. So it's -1. Okay. So with 0, position 0, philosophy, position -1, engineering. So far, so good. Yeah, so this, because I put music twice, let's access the element at position 3. This is position 0, 1, 2, and 3. So this guy is going to be printed twice. One because we accessed by index 3, and another one because we accessed it by position -1. Twice engineering. And we don't have anything at position 5. Actually, now we don't have anything at position 4 either. So we try to grab that, and Python will complain because the list index is out of range. Okay. Now, in terms of slicing meaning retrieving subsets of a sequence, we can do this slicing. So from position 0, from the first one to position 2. So the first one, 1, 2. So it will give the first 2 elements. And this is exactly the same as doing only colon 2. Why? Because the colon notation can skip one of the numbers in the indexing, and they will basically mean everything until or everything from. So this is everything until position 2, and if we put a 2 here, this would be everything from position 2 onwards. And if we actually do this, this is basically the same sequence, so we could get a copy of the list by doing this. Okay. Now, okay, so one last, second to last. Let's just remember what we have in our list L. So we've got 4 elements, right? So what would happen if we print this, which translates to get me all elements between positions 3, which is the 4th element, and the 4th element, right? We get 1. Okay, so it's important to understand how this indexing in Python works, because as you can see, the start and end indices are treated differently depending on whether we're using slicing or whether we're using individual assignment. Okay, so if we do this, it's the same, because we're starting counting from position 3, but we're getting all the way until position 4, which is one position further down. We don't have any. We still get the same element. When we do slicing, Python does not complain if we go out of bounds. So if we try to access the element at position 400, of course, it's not there. But if we tell Python to access the element between position 3 and position 400, it's just going to try this one and go all the way to the end of the list. And if it doesn't find anything beyond the first element, that's okay. We still get something. No complaints here. Okay. And finally, modifying sequences. And this is one single field. Actually, this is, beyond the fact that we can do stuff with sequences, we can do stuff with any Python object we want, with a string, with a sequence, with a collection, anything, no? And these things that we can do with them, they're called methods. And a method is denoted by a dot and then some keyword and round brackets. This is something that we will see in the next session. And the idea is that we are able to manipulate Python objects by saying object dot whatever that object allows. For example, for lists, we can add an element with the append method, and we can add something to a set with the add method. For both lists and sets, we can remove stuff with the remove method. And finally, we can, in lists, we can reassign stuff. We cannot do that in sets because they are not ordered. But in lists, we can say, and because lists are mutable, so our program can change them, we can say, okay, here's a list. I want this list to have the element at position 2 replaced by this other guy. And Python will allow that. Let's say we've got a list of 3 Welsh cities, Bangor, Cardiff, and Swansea, and a set of 3 Spanish foods, paella, tortilla, and gazpacho. If someone is not familiar with them, you don't know what you're missing. And okay, let's print these guys. And actually, what I'm going to do is only print them in one cell. Okay, so we've got original lists. We've got the guys here and the guys here. I just copy pasted and put them in different cells so we can look at them more individually. So I'll just do this again, and do this again. This will allow a bit more of isolating each of the blocks. Now what we do is to the Welsh cities variable, so this guy here, which Colab is telling us that has these 3 values inside, we're going to append Caerphilly, so another element. And to the Spanish food set, we're going to add another excellent Spanish food, which is cocido. One thing I wanted to mention is note that the set got the ordered mixed up, right? So it's not, this is not the order of the set. This is just simply telling you a set doesn't have any order. Now, after we add these guys, our lists actually contain one more element here and one more element here in the list. Now we may want to remove, and as I mentioned, it's the same keyword for both lists and sets. So we can remove Bangor and remove the paella. And as we can see here, the remaining lists have everything but Bangor, and the remaining set has everything but the paella. And we cannot do index-based reassignment in sets, but we can do in lists. So let's take the first element in Welsh cities, which is Cardiff, and reassign it to Port Talbot. And as you can see, Cardiff gets replaced by Port Talbot. Okay, and now we have gazpacho, tortilla, and cocido, and we have three beautiful Cardiff cities, Welsh cities. And finally, and this is something to be important, and this is going to be the last item, the last new piece of content, and this is it's the Python function len, which returns the length of a Python object. Some objects have a length, you know, for example, a string has a length. So this guy has a length of 5 because it actually has 5 elements in the sequence. But a number doesn't have length. Okay, so some Python objects can have a length, others can't. Turns out sequences always have a length. We have defined a list here with 1, 2, 3, 4, 5. So 5 numbers and 1/6 element, which is a nested list, which has 2 elements. But this is not a list with 7 elements. It's a list of 6 elements, but just one of them is a list. This list can be millions. It doesn't matter. It's still one element inside the outer list. So it's the length of L is 6. The length of this tuple is 2, and the length of this set is 3. Okay, almost nailed the time. I think we're gonna get carry over a bit, but not much. So yeah, so I'm going to take a small breath, drink some water. Thank you all for following along until the end of the tutorial. And we will, okay, so I just, you know, took a small break. Actually, what we're gonna do is we're going to jump straight to the exercises because now everything is quite fresh. So what we can do is this. This is something that sometimes happens with Collaboratory, you know, so you haven't been using it for a while. So Collab tells you that it's been disconnected, but that's okay. You can reconnect, you reconnect, you see here that it says connecting, initializing, connected. There you go. We have some resources being assigned. Okay. Okay. So we've prepared 5 exercises. As I said, as I said at the beginning of the course, of the webinar, we don't really need to run any code ourselves in our machines because this is something that we can probably figure out by either you know, doing these operations by hand or kind of remembering what we saw so far. But let's jump into them, no? So the idea is for each of these exercises, I will leave a little bit of time for you to think of what the output of each of these cells would be. In the case where the code may crash, and if you read between lines, this question is actually asking why does the code crash. What would be roughly the output of this statement? You can type it in the chat. What would be the output of these 6 statements, print statements? And what would be the output of these guys, these guys, these guys, and these guys, considering that we have defined a list like this? Actually, to make it easier, we will be able to see some information first and then check it out. Okay, nice. So exercise 1, let's just allow between 1 and 2 minutes for each of them, and then we can run the cell and get the output. Again, because this was highly introductory, some of these exercises are not really too much about Python, but rather about understanding how Python deals with numerical data. Okay, so what happens here is that you've got 2 variables being multiplied but with each other, and these variable, and maybe you didn't, this kind of required a little bit of out of the box thinking. This multiple assignment here actually is saying this A equals 7 and this B equals 8. So this was a bit difficult because of course you had to, kind of make an assumption of what would be the value of A and what would be the value of B. Although again, because this is Python, this would be fairly self-explanatory. So this print statement actually prints this string followed by an equal sign followed by the result of this operation, right? So this operation would be the result of doing A times B and then adding them all together. Okay. Okay, so the result of the exercise being going to be revealed in 1, 2, 3, 71, right? Because 8 times 7 is 56, plus 7 plus 8 is 71. Okay, nice. Now we can move to exercise 2, and we can ask ourselves, why would this code crash? I'm sure you all know the answer, but you're shy. It's been 2 hours already. Answer in 1, 2, 3. So basically we have a string here and we have a number here. And we've seen that Python allows, certain operations to be computed between different data types. And it really depends on the type of operation that we're running. The result may be valid or not. In the case of adding them up, the code does indeed crash, and it crashes because Python does not allow the concatenation of a string to a number, or conversely, does not allow the addition of an integer and then adding a string value. Technically, because of what we saw earlier, we could say no, but I mean 100 evaluates to true based on the Boolean values. So you could have Python say, if you're trying to add 200 and the string 100, it could probably be 200 at 1. Well, maybe yes, but that's not the way Python works. But it could be a fair comment. Here we've got an exercise where we're going to ask what's the result of this print statement. This print statement actually prints this string, the total price for, and we have a price which is 346, a number which is 45, and a fruit. I happen to like fruits a lot. The total price for, and then something else. So if you think about it, we saw that we could recast certain types, certain number types as Booleans with the bool keyword. Remember this guy? We can do the same with the str function, which is the string function. So we would take the integer and turn it a string, so we can concatenate it to this, the total price for, because if we don't do it, Python will complain because of the same reason it complained before. Here we have a string anyway, so we don't have to do anything with the type. And then we multiply the price and the number also to get the price for 45 fruits, which is not the most important result. I mean, it's not the most important answer that we were looking for. We wanted to explore how we could deal with different numeric types to put them all together in a string to be able to print it out to standard output. So the total price for 45 apples, right, because it's plural, is, and then a string, and then a full stop. If I get rid of the conversion of the number to a string type, Python will complain because, as we saw, we cannot perform certain operations between strings and numbers. Okay, so let's undo this. This is more or less what we saw in the exercise during the tutorial. So what would be the output if a equals 100? A times 2, right? The type of a, like, you know, the type of this guy here, same. This operation, a to the power of 2, so 100 multiplied by 100, and the modulo of 110. And indeed, 200, integer type, 101, 100 divided by 10, a to the power of 2, and the modulo of this guy. And finally, almost, remember that we can get the length of a sequence with the len function. So we can get the length of this guy, which has 1, 2, 3, 4, and 5 elements. We print this, get rid of this empty print because we don't need it. This is the original list. And the length is 5, right? So 1, 2, 3, 4, and 5. What happens if I add the number 1 to the third element of the list? What would be the length of the list? I repeat, what would happen if I take the 1 and put it here? What would be the length of the list? For those of you thinking it's the same because the nested element is still one element, you were right. So the length of the original list doesn't change. But the element in position 3, 0, 1, 2, 3, which was originally a 3-element set, now it doesn't have 3, has 4, and then the length of Cardiff and the length of the slice from the third element starting counting from the end. So this basically means these 3 guys. So Cardiff is a sequence of 7 characters, and we have taken the slice of the last 3 elements of the list, which are these 3. We can get rid of the len to actually verify what we extracted, and in fact we extracted a slice of this. Okay, so these were the exercises, so as you saw, not really necessary to have your Python environment up and running, but definitely have it running for prepared for the next webinar, because we're going to be covering. We will be more equipped to spend more time on exercises and less time on me talking, or at least explaining stuff, because it can be the degree of interactivity now it's going to be a little bit higher. So just to give you a couple hints about what we're going to see next time, we're going to see methods, like the append and remove methods. We're going to see how to deal with files, and we're going to see more advanced program flows. And we will start writing actual Python programs, which is what we all want to do. Okay, so thank you to the 104 people following along, and I'm going to leave the floor to Eric, because I think he's going to give some closing words. So thank you all for following along. If you like the webinar, please say so on social media. We will really appreciate a little bit of a little bit of love from the audience. Thank you very much.
Thank you, Luis. Thank you so much for your time. And thank you, everybody, for coming and being part of the webinar. I would like to just give a special thank you to the Southwest team and to CERU. So yes, I was preparing just a very short, just closing of the first part of the webinar, just to let you know we are preparing another 2 parts. So it will be a follow-up. And also, we would like to just answer some of your questions. So one of the things that I would like to ask Luis, if he has got some time, is to check the questions in preguntas or questions, and see if you would like to basically answer some of the questions, or keep them in mind for the following parts. Apart of that, I would like to just share the screen. Let's see if I can share the screen. Yes, and then show you couple things. Yeah, you can see my screen, hopefully. Oops, this one is not the one. Let's see if I can just show you now. And just basically to give you just some quick access to CERU. So to just keep you in the loop for the following events, I want to just basically show you the following events. Okay, you can see that. So just a quick reminder about what we are. So we are a society, the Society of Spanish Researchers in the UK, and some of our work is to connect the R&D institutions and the research, most advanced research, to the general public. Also, if you go to the website, which is below, or you access to the information this in the website, you will be able to see all the events that we are preparing and all that. If you want to send us some questions, you can just email us into the left, bottom left side of the screen, where you can see the address. And thank you very much. Thank you very much for being part of the first webinar. And that's it, basically. Luis, do you want to answer some of the Q&A questions, or do you want to leave those ones until the end? Luis?
Yeah, I'm here. Okay, so well, I saw some of them. Actually, some of them were already answered, but just as a quick overview of them. So they can at least have any type of object. Yes, it can have any type of object. You don't need to have a list with a consistent type across all elements. And as we saw, we could throw anything we wanted, even null values, Python reserved keywords, etc. There was a question saying it says type error integer object is not callable, but I don't know where. Yeah, that was probably because of the in the string and number operation. So if you try to add up a string and a number, it really depends on the order that you're using. Python's error will be slightly different, but no, wait. I don't think this error is coming from there. I think this error is coming from the print function, but I don't remember exactly if it was that if that was the case. But in any case, that was and that was exactly the case where I mentioned that the error is not really self-explanatory, because so callable means function. So in Python you call functions, but the numbers, and that number wasn't assigned, so that we had x equals a number or something. That could not happen because you could not have a number being assigned to a number, and then you couldn't print that. Yeah, so this floor division operator, I think it's being very well explained here. I didn't really go over it because it's not used very often. However, I did stop a little bit on the modulo operator. When the progress bars when we are, for example, installing an application in our machine. So it says 10% completed, 20% completed, 30% completed, and so on. This is almost always done using the modulo operator, because it says after a certain number of iterations in the installation program have happened, then print to the user the progress up to that point. Now, how do I know I have done this all the time? So this consistent jump between, let's say, 1,000 steps, 2,000 steps, 3,000 steps, because I have a counter of the steps, I divide by 1,000. Every time the modulo is 0, I can print the progress bar. So this is actually very useful for especially logging and seeing what the progress of the program is, and so on. And finally, we had a question on whether if we wanted to define a string in English, including the single quote, like it's time to, what would be the Python command to include it? So you can do two approaches. One, exactly what you did in the question, so having double quotes, and then Python won't complain, as we saw also the reverse case with linear algebra. But if you enclose it in triple quotes, they will automatically assume that everything you have in there is a string, so you don't have to really care too much about whether you're using the same or a different quote sign for your string. And I think that kind of covers all of them. I mean, there were not many, so we could kind of cover them in a couple of minutes, so that's good. I think you're muted again.
Thank you very much. Yeah, thank you very much, Luis. Yeah, so there's some questions about when will be the part 2 and when will be the following part. So I would recommend you, there's 2 ways to do this. So if I share my screen, let me just share my screen again. I can show you the website briefly. Hang on, give me a second, and I'll just go to my website. Let's see if I can just share it now. Okay, sharing the screen. And then in the screen that briefly will appear, okay, here. So you can basically see, okay, so basically here you can see the different options in the website. So if you go to events, in events you can see the latest events. There is actually another event in June. It's another Python webinar from London. So it's about the Society of Spanish researchers in the UK computer workshop. It's a part 2 of another physical present webinar that was event that was in London in March. It's not a second part of this one, but you could just maybe have a taste of the other event in Python. We'll do this event hopefully during the summer. The second part will be during the summer. We don't want to do many events at the same time, so it would be very confusing and very it won't be ideal for us to run all the events the same day or the same week. So potentially in July is a good month, so we'll keep you informed. If you want to access and then get some newsletters from us, you can always go to membership in our website. And then in here you have, as you see, you have CERU as a friend, for example, and then you can just, this is just per year, so the amount of money per year, but you don't need to access and pay for getting the information, of course not. You just need to just contact us in the through our basically through our email, the one that I saw before, this one, info@sruk.org.uk, and then we'll get you informed about the following events. So yeah, I think that that's pretty much everything. Thank you very much for coming and being part of this event today. Thank you, Luis. So thank you so much for taking 2 hours non-stop. That is like a marathon, and explaining all of these introductory part. Thank you very much, Luis. Thank you very much, everybody. Have a nice week.
Thank you, guys, and see you next time.
See you. Bye now.
Bye.